question is, why do chatbots discriminate?
I have got the answer. They reproduce the discrimination found in society.
Couldn't that just be a prejudice?
There are many studies that support my view.
Yes, but these studies back up their results with statistics.
What's the problem with that?
What if discrimination comes from statistics?
You'll have to explain that in more detail.
Statistics were developed for the purpose of discrimination.
But statistics are mathematics, aren't they?
The original fathers of statistics, Galton and Pearson, were actually just amateur mathematicians. They lived in England at the end of the 19th century and believed in the superiority of their own bourgeois class. They wanted to prove the inferiority of the working class mathematically. They believed that the poor, who were considered stupid, posed a threat to their own ways. They introduced classifications and invented the term moron as a technical term for stupid people.
What imbeciles!
They classified people who were even stupider than morons as imbeciles.
Fair enough.
It was Galton, Pearson and Fisher who introduced the tools we use all the time today. They were interested in using mathematics to justify discrimination scientifically. To this end, they developed statistics as a tool.
I remember. You made a whole series of videos about it. You'll find the links below.
There are, of course, psychological reasons why people discriminate, but discrimination can most easily be explained through statistics.
But how exactly does one discriminate using statistics?
Statistical methods make discrimination easy. This is because discrimination always refers to group membership. If a white man disadvantages another white man, that is immoral, but not discrimination. But if a white man disadvantages a black man simply because he is black, then that is discrimination. Because the reason for disadvantage is the person's group membership, in this case a group of black people.
That's quite logical.
This is precisely how data analysis works. It defines people by their group membership. Discrimination requires that an individual is put into a group based on probability.
Why is that?
Because an individual does not have the same probability as a group. It is a definition error. An individual is then defined as an element of one or more groups and is assigned probable characteristics of the group.
How else can it be done?
But there is a difference between a set with multiple elements and a set with only one element, known as a singleton. The probability of a singleton is not the same as that of a larger group. This is why statements about the probability of a group cannot be applied to an individual.
So it is a mathematical problem after all.
Not directly, because it depends on whether a person is defined as an individual or as an element of a larger group. In other words, it depends on which category they are put in. This distinction is important because the probability is calculated differently in each case.
Can you give me an example to illustrate what you mean?
Yes, perhaps with playing cards. Let's say there are 100 playing cards, 80 of which are black. You can check this by turning over all the cards to see that there are indeed 80 black ones. And if we turn over just one card, then there is an 80% chance that it will be black.
That's obvious, but where does discrimination come in?
The assignment of probability values depends on the size of the set. If you only have two cards, one black and one red, then the probability of each card being black or red is 50%. Since there are only two possible outcomes, the probability cannot be higher or lower, of course.
That's right.
The probability value can never exceed the initial quantity. For a sample size of 100 people, the smallest possible probabilities are 1%, 2% or 3%. The value cannot be 0.5%, for example, for a quantity that has only one element if it consists of a person. The probability for a property can only be 0 or 100%, that is 0 or 1. In order to obtain a value other than 0 or 1 for a person, they must be assigned to a larger group. This means that they are no longer an individual or singleton, but an element of a larger set.
I'm wondering if there are any complicated ways to work out the answer to this problem.
Complex probability calculations do not change the core problem of whether a person is defined as an individual or as part of a larger group. The problem is not how accurate the probability is, but to which category its elements belong to. In complex calculation, such as Bayesian statistics, a person remains only one element of a group, from to which the probability values are assigned.
But people often discriminate against others because they hold arbitrary prejudices.
Yes, but computers don't have this prejudice. They only have data, but no moral judgments about that data. Nevertheless, they use this data to discriminate. An AI only arrives at a moral judgment through its calculations. It identifies a high probability of a group possessing a certain characteristic and then assigns each individual in that group the probability value of the group. But an individual can only have a probability of 0 or 1. Any other probability assigned to is incorrect. If this incorrect assignment leads to disadvantage, it is discrimination.
Okay, I'm starting to get it. So, discrimination isn't always based on personal prejudice, but rather on how we handle those biases.
In discrimination, the reason or cause behind a characteristic is simply ignored. Instead, people are defined by the group they are part of. This category error can be illustrated using the example of gender assignments.
Women, in particular, are discriminated against.
If you assign men and women to two groups and create a catalog of random characteristics, you can specify the probability of each characteristic occurring in the group. For some characteristics, the values will be distributed evenly across both groups, but for others, you will find statistical differences between the two groups. You can observe that certain characteristics are more common in women or men, and you can then label these characteristics as female or male.
And what is typically female?
That doesn't matter at all. Discrimination does not require specific characteristics. Discrimination is essentially arbitrary anyway.
But are there any traits that are unique to women?
Of course not. Otherwise there would be no probability assignment. No matter what characteristics you can think of, none of them are exclusive to one group or another. Women can have male characteristics and men can have female characteristics. The number in each case is irrelevant. Even if a characteristic is not shared by only one person in the group, the probability of the entire group having this characteristic is less than 100%.
Oh, and then you get a value that can no longer be applied to an individual.
In each individual case, a person possesses both male and female characteristics, and only statistically do female characteristics predominate in women and male characteristics in men. The higher probability is not the result, but rather the prerequisite for a group membership, because the groups are named according to the probable occurrence of a characteristic.
When we talk about male or female characteristics, we are using clichés.
That doesn't say anything about any individual. In a specific case, the behavior of a woman or a man can only justifiably be classified as typically female or typically male after she or he has behaved in this way, thereby confirming the trait regardless of its probability value. Nothing has been proven, it is just a label assigned to a behavior. If you describe someone as having a typically female or typically male characteristic in this way, the conclusion is a tautology.
Then you say something that you've already defined as such.
As Brookes and others have pointed out, chatbots use words embeddings. When words frequently occur together, algorithms group them into clusters. In their study, they show that a word such as boss is associated with man, while a word such as housekeeper is associated with woman. They suggest separating words from gender assignments as a solution.
Problem solved.
But this way, only a few discriminations can be prevented. Data processing not only reproduces the prejudice that exists in society, but also creates new ones from the data. In this way, AI can also develop new forms of discriminations that we have not yet recognized. This happens when AI assigns a person to a group and then transfers common characteristics of that group to the individual.
But is it always discrimination?
No. Strictly speaking, discrimination only occurs when someone is disadvantaged as a result. But in its most general form, it is simply a misjudgment. The damage then lies with the person who applies the misjudgment. In any case, they can suffer damage as a result of that misjudgment.
Tackling discrimination is good for everyone. It helps the victims and the people who discriminate.
There are also cases where statistics make sense. For example, in marketing campaigns, the whole point of advertising is to encourage people to make purchases as often as possible. advertising tries to appeal to the people who are most likely to buy the product. It is not known which individual will actually buy the product, and this is irrelevant because what matters is the quantity of products sold. Since only the total numbers are relevant, a probability estimate for groups is sufficient. In individual cases, an advertisement may appeal to the wrong people, but these inaccuracies are not important as long as overall the right audience are targeted and the total number of products sold is sufficient.
So it turns out statistics aren't always so bad after all.
Statistics become a problem when you try to work out cause and effect from statistical data. For example, when you transfer characteristics of a group to an individual based on the membership of that group. A statistic only shows how often something happens. It is not based on causality. The cause of the characteristic may lie elsewhere entirely. Statistics create prejudice, but not correct judgments. Confusing the two leads to discrimination.
This point has actually been made repeatedly in the literature.
So, the bottom line from all this is that data processing and AI fundamentally discriminate. Chatbots that calculate their next tokens statistically are bound to discriminate. This is not due to any bias held by the engineers. It is a statistical method itself. After all, Galton, Pearson and others developed this method for this very purpose.
What should we do then?
If we want to combat discrimination, we need to change our methods.
I don't think that will happen anytime soon.
Then nothing will change at all. But we shouldn't give up hope. After all, AI is still a very young field. A lot has happened very quickly so far. People said move fast and break things. But if we take more time and glue the pieces back together, we can develop better methods.
So there's plenty to do. If you have any ideas, please let us know in the comments. I hope you enjoyed the video. Don't forget to subscribe and see you next time.